Today's lesson on significant figures. Say these are numbers that tell us how exact a measurement or calculation is. We have 5 rules for determining which numbers are significant. The first one here, all non-zero digits, so any number 1 to 9, that's not a zero, non-zero, are significant. So that means we're only going to focus on those zeros. Our second rule then, really the last few here, focusing on those zeros. Zeros between any non-zero digits are significant, so we call these sandwich zeros or Oreo zeros. So example here, that zero between our non-zero digit and non-zero digit is significant, so there all 3 are significant. Same thing here, it doesn't matter if I have 1 or 3 or 15, these are all going to be significant. Our third rule, zeros to the left, so keyword there, left, of the first non-zero digit are not significant. These are just placeholders. They're going to show us how small our number is. So our example, 0.008, only that non-zero digit 8 is significant in this case. A little tip, when you're counting sig figs, so I give you an example, hey, tell me that they're the first 3 digits, and what are the first 3 significant digits? Your best bet is to start counting sig figs from that first non-zero. So find that first non-zero, just like you would read, and then count left to right, just as you would read. Our fourth rule of 5, so zeros to the right of a decimal and or at the end of a number with a decimal are significant. So example 5.0, there's a decimal there. 2 sig figs, so that non-zero is of course significant, and then the 0, because it's at the end of a number with a decimal or to the right, makes that significant. Same thing in our next example, there, that 0 at the end. Same thing, all numbers there are significant. And then our last rule, I put it on the same board here so you can see kind of the difference. All zeros, a 0 is not significant when it is at the end of a number without a decimal. So without. Examples here, 9,480. Well, there's no decimal here at the end. So in that case, only these non-zero digits will be significant. So only 3 sig figs there. All right, enough of the rules. Now to kind of put this into practice a little bit, rounding to proper sig figs. So, give you an example, whether it's in lab or a homework problem. It's cool that you know how many sig figs, but it's okay, how do I report my answer correctly? This is how. So rounding to proper sig figs, find the number of sig figs you need, 2, 3, whatever the number calls for. And then look at that next digit to the right. 5 or higher, round up, just elementary math stuff. 4 or lower, round down. Just a little tip again, make sure your answer still shows the correct number of magnitude. So don't round 1,000 to 1, and I'll show you an example of that here. Make sure it still shows how big or small that number is. So example here, round 4,351,023 to 2 sig figs. Well, okay, first 2 sig figs are 4 and 3. That doesn't mean I just cut off everything else. So I look at that 4, 3, look at that next digit to the right, it's a 5. That means I'm going to round up. And when we do that, our answer comes out to be 4,000 4, and then I'm just going to convert everything else to a 0. And by not putting a decimal here, those aren't significant. So there's my 2 sig figs. And then just some practice problems to go through here together. Again, you can pause this, do them by yourself, and then see what I come up with. So first one, how many sig figs are there in, well, in that first one, before, so to the left of that first non-zero, not significant, not significant. So in this case, there's just 1. Question B, well, starting from the left, hey, that's a non-zero, automatically significant. Looking, I'm going to kind of skip ahead a little bit. There's another non-zero, so that one's significant. Have a couple sandwich zeros. And then a trailing 0 with no decimal. So in this case, not significant. I have 4. C looks very similar except with a decimal, so we know those two are. We know those sandwich zeros are. And now I have a decimal, so any 0 to the left of that is, so it has that decimal at the end. And then D, 0 up front, not going to count, just a placeholder, another placeholder, hey, non-zero digit, see another non-zero, and then a couple sandwich zeros. So a couple practice, just determining how many sig figs are in each number. Number 2 here, round each of the following to 2 sig figs. So, okay, find those first 2 sig figs, 1, 2. Look at the next number, it's a 5, so it's going to be 1, 2, because I rounded up, and then I still need to show that it's 120 or somewhere bigger than 100, so 12 is nowhere close to that. So make sure you add that 0 to show magnitude. In B, find your first 2 sig figs, placeholder, 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 just showing us how small. 1, 2. Look at me, another 5. I must love 5s. Gonna round up again. So this answer here gonna have to be small. 0.234, and then don't forget to round up. We cut everything else off there. You can put the zeros, not needed. And actually, if you did put those zeros in, since it is to the right of a decimal, left, right, this is backwards L, it's right. Those actually are significant, so you don't want those zeros there. Letter C, again, find those first 2 sig figs. Found them. And then look at the next number. Hey, it's another 5. Gonna round up, so do that. 9, 8, comma. Well, I still want to show magnitude, so make sure 98,000. Because 98 is nowhere close to 98,000. Show how big. Last one, first 2 sig figs. Kind of tough here because that second number is a 0. Well, if we look, that 0 is significant since it is a sandwich. So, kind of weird, kind of different from the other ones, but it is significant. Look at the next number, it's a 4. Hey, we're going to round down. And then that just means keep it the same, so 1.0 is correct there.